So here are the parts. So the radical. So the parts of a radical. The radical sign is the actual thing, right? It's not a division sign. Kind of looks like division, but it's not a division. Okay. The number in front or whatever is in front is called a coefficient. So if there's something in front of the radical, it's called a coefficient. Okay. The root we dealt last semester. We only dealt with square roots, right? Square roots. So if it's a square root, there won't be a number there. Kind of like the square root of 16, there is no number there because it's a square root. Today, we're going to deal with things that are third root, fourth root, fifth root. There will be numbers there. There will be 3, 4, 5, whatever number root they want you to do. Okay? We call that number the root. Sometimes it's called the index, but most of the time it's called the root. Okay? And then whatever's on the inside. So in this case, 16, it's called the radicand. So you don't really see that a lot. You'll just see like the number inside or whatever's inside. But the stuff inside is called the radicand. That's the actual name for it. Okay? So just like last semester, if the root isn't there, it's a square root. Okay? 2 means square root. Square root. Okay? So if there's nothing there, that just means square root. If there is a number there, that means a specific root. Okay? Okay, so we're going to follow these steps to do every problem. They're going to look a little different, but essentially we're just following these steps. We're simplifying. Okay? Simplifying means breaking down as far as we can. All right, so these are the steps we're going to use. So I'll show you on number 1. So this one's a square root because it has no number there. It has no number for the root. So if it has no number, it's a square root. It's 2. Okay? So the first thing we always do is factor tree for everything that's underneath the radicand, 1/12. So factor tree is like you guys have been doing since elementary school, right? Or junior high, elementary school, I think they start doing this factor tree, right? We want to simplify everything as far as we can. We're going to do that with 112. Okay? So over here to the side, that's the first thing we're going to do. Factor tree for this, in this case, 112. We always do that for numbers. Okay? It doesn't matter where you start. You can divide it by 2. You can divide it by 4. Whatever goes in. It doesn't matter where you start. You'll always end up in the same spot. Okay, so if you're not sure, just use your calculator. 112 divided by 2. 56 and 2. So we say 56 times 2. And then you keep breaking down until you can't. 56 is 7 times 8. Seven. What's the only way to make 7 doing multiplication? 7 and 1, right? That means we're done. So anytime we're done, we circle the number. 8, I can keep going. 4 times 2. Same thing with 2. I can't break down 2 anymore. But I can 4. 2 times 2. And then there was a 2 up here that I also had that I didn't that I had 56 times 2. Okay. So now I'm going to rewrite 112. But instead of 112, I'm going to write what its factor tree says. So I have a 7. And then I have 4 2s. Right? Factor tree means multiplication. So that's why I put multiplication dots in between. So 112 is the same thing as 7 times 2 times 2 times 2, right? If you were to multiply it, you'd get 112. So I didn't change 112. I just changed the way it looked. Why? For my next step. So it's a square root. Since it's a square root, we're going to look for pairs. So the second thing we do is circle pairs. For square roots, we circle pairs. If that was a third root, we'd look for triples. But since it's a square root, I'm looking for pairs. Okay? So I'm going to circle pairs. I got a pair of 2's here, and I got a pair of 2's here. 7 doesn't have a pair, but the 2's do. So how many pairs of 2's do I have? 2. So that means 1 2 can come out here, and another 2 can come out. So that means in front now, I'm going to have a 2 times 2, because one of the 2's came from the first pair, one of the 2's came from the second pair. Once they come out, they're no longer in there. What's left on the inside? 7. 7 can't come out because it only has it doesn't have a pair. Anything you bring out to the front, multiply. So it's going to be 4 times the square root of 7. Done. That's simplifying. Okay. So you're always going to start by breaking down. And then you're going to decide, am I looking for pairs? Pairs means square root. Triples means third root. 4 of a kind means fourth root, and so on and so forth. Okay? So this one is square root. So we look for pairs. All right. Let's try number 2 now. Try number 2. 96. Okay. Again, this is still square root. Looking for pairs. So the first thing we got to do is break down 96. So you can divide it by 2. You can divide it by 4. I think I divided by 2. It doesn't matter where you start. You'll always end up in the same spot. 2 times 48. That's one way to start. 2 cannot be broken down anymore, so I'm going to circle that. But 48, I can't. 8 times 6. 8 is 4 times 2. Circle the 2. I got a 2. 4 is 2 times 2. I get 2 more 2's. Now let me go to the 6. 6 is just 3 times 2. 3 I can't break down anymore. 2 I can't break down anymore. Okay. Broke down 96 as far as I can. It's got a 3 and a bunch of 2's. Next is rewrite 96. 3 times 1, 2, 3, 4, 5 2's. It's square root, so I'm looking for pairs. How many 2's can move to the front now? 2, just 2. I know some people see 4 of them. Oh, there's 4 of them, so 4 can move up. No, just 2 because there's 2 pairs. The number of pairs can move out. So I got a 2 here and a 2 here. So that's going to be 2 times 2 in the front. What's left is a 3 times 2. 3 times 2 is 6. 2 times 2 is 4. Done. Broke down as far as you can. Okay. All right. Let's go to example number 3 now. So example number 3 is the same. I just include letters with the numbers. Actually, letters are easier. Letters are actually easier to do because letters you can do in your head. Numbers, you need the factor tree. But letters you can do in your head, and I'll show you. Okay, so underneath, we have 54, x to the 6th, and x to the 5th. I'm not worried about the x in front. That's just coming along for the ride. So I'm going to break down 54. That's the first thing. Break down the number. I think 27 times 2, 9 times 6, wherever you want to start is totally up to you. Just keep breaking down until you can't break down anymore. Once you get there, circle. Once you break down, rewrite. So I have an x in the front that was already there. 54 is now going to be 3 times 3 times 3 times 2. How do I deal with the x to the 6th? Well, x to the 6th means x times x times x times itself 6 times. That's what it means. So I'm going to write it that way. Y to the 5th means y times itself 5 times. That's what that means. A number multiplied by itself 6 times. A number multiplied by itself 5 times. We don't know what that is, so we use letters. That's all that means. So this guy, we're looking for pairs again. It's a square root, so we're looking for pairs. So I'm going to circle pairs. Got a pair of 3s. Pair of x's. Pair of y's. Okay. I have one pair of 3s. So I have a 3 that can come out. The x was already there. How many pairs of x do I have? 3. So 3 x's can come out. Well, x times x times x is x to the 3rd. How many pairs of y do I have? 2. So, in other words, y squared comes out. So the x in the front was the one that was already there. The 3, I had a pair of 3s. X to the 3rd because I had 3 pairs of x. Y squared because I had 2 pairs of y's. Okay? Now what's left over? 3 times 2, 6 times y. So in the front, let me clean it up. I have an x here, an x to the 3rd here. So how many x's do I have? 4. So I put 3 in the front, x to the 4th, y squared, times the square root of 6y. Done. That's as many I can do. I can't take out 6 because it's 3 times 2, not a pair. Can't take out y because it doesn't have a pair anymore. It was left over. Okay. All right. Number 4 is just like number 3, except now it's 3 of a kind. It's the third root now. That root is no longer squared. It's a third root. The only difference is that now I'm looking for triples. Not looking for pairs anymore. I'm looking for three of a kind. That's the only difference. Everything else is exactly the same. Okay? I'm going to break down 750. I'm going to break down x to the 10th and break down y to the 10th. And then the y in front is just going to come along for the ride. Y squared, sorry, the y squared in the front. Okay, so 750. It's a big number, but it ends in a 0, so that means it can be divided by 10. So 10 times 75. Ten is 5 times 2. 5 can't be broken down anymore because it's just 5 times 1, and then same thing with 2. 75, you can go 3 times 25. And then 25, you can go 5 times 5. So 750 has 3 5s, a 3, and a 2. X to the 10th. I don't want to write x times x times x. It's going to be long, right? So I'll show you a shortcut. It's going to be a long x times x times x times x. Same thing with y. So I'll show you a shortcut. Some of you might know this shortcut already. So let's start with 750. Looking for pairs of 3, or sorry, not pairs of triples, 3 of a kind. Triples here. So I already have y squared in the front. How many 5s can come out in front? 1. 1 5. Not 3, 1 5. Okay? A lot of times you see 3. Oh, 3 can come. No, only 1, because there's only 1 triple. 3 and 2 have to stay. Do this part in your head. How many x's do I have on the inside?
10.
How many pairs of 3 am I going to have? Or how many triples am I going to have? If I have 10 total. 3 triples. So let's write that out there. Y to the 3rd. Do I have any left over? 1 is going to stay on the inside. Oops, sorry, that was x. Y is going to be the same though, right? Because I had the same number? Okay. Leftover. 3 times 2, which is 6. Do I have any x's left over? 1. Do I have any y's left over? 1. Clean it up a little bit. So I'm going to put the 5 in front. Let's go in alphabetical order. X goes first. How many y's am I going to have in front? 5. Yeah, 5 y's. Okay. All right. So when we're doing practice, especially when we're doing practice on Delta Math, don't forget about the root. Don't forget about the root there. Sometimes when you're typing it in, you forget about this guy, because if it's not there, it's the Delta Math is going to think, oh, it's a square root. It wasn't a square root, right? It was a third root. So don't forget about that. There's a little button there that I'll show you tomorrow. Okay. All right. Okay, so now let's move to number 5. In math, what does the word product mean? Multiply. It means multiply, right? Multiply. Well, what are you multiplying? You're multiplying this guy, and this guy. So how do we multiply these two guys together? You multiply what's in front. So 10 times 4, 40. Since they're both square roots, I can multiply the square root of 10 and the square root of 12. What's 10 times 12? 120. There's the multiplying part. It's done. The last step is simplify. Do what we've been doing. Simplify 120. Simplify 120 till you can't simplify it anymore. Got a 5, a 3, and some 2s. 3 2s. This one is a square root, so I'm looking for 2 of a kind. Doubles, pairs. I only got 1. There's only 1 doubles. There's only 1 pair in there. So how many 2s can I take out? 1. And what is that 1 2 going to do with the 40? Multiply. So you get 80. Everything else stays in. 5 times 3 is 15, times 2 is 30. Done. Okay. Number 6 is the exact same type of problem. It's just you have third root. You're going to do the same thing. You're going to do the same thing. First thing is, let's put them all together. Now, I'm not going to multiply 108 times 4 right now. The reason I'm not going to multiply those is because my first step is to break down everything. So why do I want to multiply something I'm going to break down in a second? So how do I write it? I'm just going to write 108 times 4. I'd rather break down both of those than multiply them and make 400 and something and have to break that down. How many D's am I going to have? 10. Okay. So I got this guy, I got this guy, and I got that guy. Break down 108, break down 4. Well, 4 is just 2 times 2. That one's easy. 108, 54 and 2. 2 times 54. 54 is 9 times 6. 3 times 3. 2 times 3. So 8, all together, I'm going to have 3 2s and 4, no, sorry, 3 3s. And 1, 2, 4 2s. And D to the 10th. Instead of writing 3 times 3 times 3 times 3, you can write 3 to the 4th. Oh, wait, how many 3s do I have? Yeah, I have too many 3s. Should be 3 3s. Yeah, instead of having to write all those 2s and 3s, you can just put 3 to the 4th and 2 to the, or 3 to the 3rd and 2 to the 4th, just like you did D to the 10th. You can do that too. Doesn't take up as much room. Triples. Triples. I got 3 3s, 3 2s, and some leftover stuff. How many 3s can come out in front? 1. How many 2s can come out in front? 1. How many Ds can come out in front? 3. Yep. 3 Ds can come out in front. Okay. Leftovers. I got a 2. Were there any Ds left over? There's 1 D left over. So multiply, I get 6D to the third. 2D. Okay. All right, so we have one more, and then I'm going to give you one more to do on page 23, and then we'll be done. So 2 more problems. So we just did 2 multiplication problems, right? We did multiplication for 5 and multiplication for 6 before, right? Last one's division. Well, for division, first thing you're going to do is same thing I did for multiplication. Put them all under the same. So I'm going to put them all under the same square root. Okay. So before I do my factoring, I need to divide first. 9 goes into 180 how many times? 20. Okay, so if I have x to the 9th divided by x to the 4th, when we multiplied, what did we do with the powers? Added them, right? So when we divide, we're going to do the opposite. Subtract. So how many x's am I going to have left when I divide these two? 5. And y to the 4th. Now that looks like a problem I've done before. Now I can start doing my, once you do your division, then you can start breaking down. So I'm going to break down 20, 5, x to the 5th, and y to the 4th. So 20 is just 4 times 5 or 2 times 10. So 20 is going to be a 5 and a 2 and a 2. X to the 5th, y to the 4th. Look for pairs. Got a pair of 2s. How many pairs of x's am I going to have? 2. With 1 left over, right? How many pairs of y's am I going to have left, or have 2? With none left over. So what's left over? I got a 5 and then an x, right? Done. Okay. All right, so I'm going to pass out the tape, but we're going to do one more problem in 23. On page 23, we're going to do one more problem, then we'll be done for today. I'm going to give you a practice problem. All right. Okay, so here's simplify. That guy. Okay, so this is the fourth root. All that's going to change is we're just looking for 4 of a kind. That's it. Everything else stays the same. So 256, when I break down 256, I get a lot of 2s. I get 8 of them. So I put 2, instead of writing 2 times 2 times 2 8 times, I just wrote 2 to the 8th. X squared, y to the 16th. So if I have 8 2s, how many pairs am I going to have? 4, right? So that means 2 to the 4th can come outside. None left over. How many groups of 4 x's am I going to have? Not enough. I don't have enough x's. I only got 2, so that means those 2 got to stay inside. Y's. How many groups of 4 y's am I going to have? 4. So do I have any 2's left over inside? No. Do I have any x's? Yeah, x squared, right? Do I have any y's left over inside? No. So let me clean this up a little bit. 2 to the 4th is 2 times 2 times 2 times 2. Wait, sorry, I did this wrong. Sorry. I thought it was, so how many groups of, if I have 8 2's, how many groups of 4 do I have? Just 2. So it should have been 2 squared. That was a mistake right there. So it should be 2 squared, not 2 to the 4th. It would have been 2 to the 4th if I was looking for pairs, but I'm not looking for pairs. So 2 to the 4th is just 4. Or sorry, 2 to the 2nd is 4. 2 squared is 4. Y to the 4th, and then we have the 4th root of x squared. Done. Okay. That's it. So make sure you tape it into page 23. Tomorrow we'll do some more practice. We'll do some practice like we did last semester, and that's it.